Okay, so with a parabola, like with the straight line graph where you need to know that it's y equals mx plus c or ax plus b, it doesn't matter, whatever letter, you can put any letter in front of the x and the intercept, but we call it y equals mx plus c in caps. You also need to know that your parabola is y equals something x squared plus something x plus something. And these general form of the equations are like your North Star, your guiding light to help you figure out what is actually happening. So going back to the straight line, if your m is positive, you know, it goes upwards. If your m is negative, it goes downwards. If your c is positive, it intercepts above the x-axis, and if it's negative, it intercepts down there. So with your parabola, you have a number in front of the x squared. So for example, what if it's positive, say 2, right? 2x squared. Positive means smiley face. Okay, so if your a is positive, it means it's a smiley face.
Okay.
Okay. And if it's negative, it's a sad face. Okay, now C is the same as with your straight line graph, right? So your C is your y-intercept.
Okay.
So this would be your C here. So whatever C is, it would be where it intercepts the graph. Now, what we notice about these graphs is there's a turning point. So we see there's a turning point, there's red, these things in red, that's a turning point. Now my turning point, the x value of my turning point, I can actually get from this equation by just going negative b over 2a, and that's always the same. So negative b over 2a will give us the x value of our turning point, which you can then use to figure out the y. So once you get so this is your x value of your turning point. Now, in order to figure out what y is, you simply just put that value, your x value, back into this equation wherever you see an x. So you would then just put your turning point, like if it's an x there, and just sub in. So you just sub your x back into to get y. And that would then tell you your x value of your turning point. So you'd have an x and a y value there at your turning point. Okay, so your x you get from there. And then when you sub it back into this thing here, you'll get your y.
How would that look like if we had
yeah, let's do an example. Okay, so we've got let's do a function. And we'll say y equals negative x squared. Let's make it plus 3x minus 2. Make it plus 2. Make it plus 4. Should we make it plus 4? Let's make it plus 4. Hope this works. Okay, so if we look at this parabola, we know that it's a sad face. Okay, so because our a, remember our a is equal to -1, so we know that it's a sad face. Okay, the turning point, we can use the turning point formula, which we'll get. So we know that our turning point is equal to negative b over 2a, right? Negative b over 2a. We can see our b is our 3.
Okay.
And then our c, that is our
y-intercept.
yeah, I should have said b is 3 in yellow. B equals 3, and you're right, yeah. C is equal to 4, that's our y-intercept. Okay, so you grade 10 now.
Yeah, unfortunately.
Grade 10. I've hardly seen you this year, so I forget. Okay, so we kind of know that our y-intercept is going to be sort of 4 over here, and it's going to slope downwards.
Okay.
So we're not quite sure though where. So those are just what we know just from exploring this, but we want the steps to drawing an equation to be the same. Now, when we draw a straight line graph, we always just get the x-intercept. So let's make that the same method for parabolas. So we'll just get your x and y, you get your x and y intercepts.
Okay.
Okay, well, the first one is easy, right? That's just y equals 4. We've explored that already.
Yeah.
Now, the second one is to say, well, to get our x-intercept, we make y equal 0. So we get 0 equals negative x squared plus 3x plus 4. This would be easier to rather go x squared minus 3x minus 4. We can do this because I'm dividing through by negative 1. So if you see 0 equals negative x squared, you can just change the sign of everything, and that will then give you a new equation, which is easier to figure out. So
Why would I change the sign of everything?
oh, because to factorize this is much harder than to factorize with a negative. Because when you factorize, you have these.
Yeah, yeah.
But if you have your silver calculator, it doesn't matter because you can say negative 1, 3, and 4, right? And your silver calculator will figure it out. Have you done that before? Where you've factorized using your silver calculator?
Yeah, I don't have the silver calculator though. But we did it. We did it vaguely last year.
Okay, so this, what we do is we get the factors of 4, which will be 4 and 1. And now negative 4x plus 1x will give you the factors. What I will do is I will send you a link to that silver calculator and a link to the video that will change your life. It's basically just takes the difficulty out of factorizing. Now you work backwards from the answer, but I'll send you that video. But for now, this is it factorized. And so you know that then x minus 4 equals 0 and x plus 1 equals 0. And so your values are x equals 4 and x equals minus 1. So now I know the 1 is 4 and the 1 is minus 1. So I'm almost there, right? I can kind of there, but and I know that it's going to be sad face because of the green. Okay, so yeah. Let's put it in green. Let's actually draw the thing in green. It's going to go through there. But now I don't actually know my turning point. This is 4 here. So this was 4 and this was 1, minus 1. But I can get my turning point using my turning point formula. So let's just move this down a bit. So that will be 2. Turning point. Now the x value of the turning point is negative b over 2a.
Yeah. So would negative 3 over 2a.
Excellent.
What do we say? Is negative 1. So negative b 2 times negative 1, and then solve that, and we'd have the turning point. Wait.
Yeah.
But wouldn't it only be what's it? One, yeah, it's one number. How
Yes.
do I put that
Yeah.
over
So
there?
you know that it's going to be 1.5, which is actually halfway between -1 and 4, because that makes sense because your line of symmetry is there. So if I went -1 plus 4, I'd get 3, which when I divide it by 4 would be 3/2. So it does work. It's 1.5. But of course, that only is the x value. I then put the x into the original equation to figure out my y. So that would be y equals 1. Sorry, there's a negative there. Negative 1.5 squared plus 3 times 1.5 plus 4. Okay, so 1.5 squared, well, we know 225 is 15 squared, so this will be 2.25 negative. This would be 4.5, and this would be 4. So it'd be 8.5 minus 2.2, which would be 6.25, right? You can just stick that in your calculator. Okay, so then we know it's 1.5, and so the turning point, let's do that in red, would be then 1.5 and 6.25.
And then do we estimate?
Yeah, that's done.
I'm saying if we have to draw.
Yes.
Would we?
So they okay. So let's look at what they're looking for. They want the intercepts, which we've done, and they want the turning point, which you've done. It's not. We don't have to like draw each little spot in between. They're looking for we have put the ticks there, there, and there. So we can estimate, and it's fine if we get the marks like that. It's not like when you in grade 6, 7, where you have to draw each little line, and they when you look at the memo, you'll see they're marking the 4 points here. Okay, so that is parabolas. I'm going to stop the recording there.